with the concept of data type. So before going in detail, I would like to request you, all of you, to do a like and subscribe to the my channel so that it will keep on motivating in making more videos. Okay, now we see that we need data. Then data can be of different type, and in order to store the data, our programming language provides some default data types as well. So there are some different type of data types, what we can say. So these are the different ways we can store the data. One with the primitive data type. Okay. Second one will be the reference data type. So what are the primitive data types? It is provided by default by the programming language. Okay. In Java, we have the like byte, sort, integer, then long, then double, then float, then character, then boolean. Okay. Similarly, for the non-reference one, that will be covering at a later phase. So mostly these are kind of complex data types, which you can say the user-defined data types or the secondary data type. These are stored the reference to object in the memory that we'll discuss later, which some of the examples can be string or can be array, can be classes, can be interfaces. Now to summarize that, like to let's put this map in the brain. Okay, what is the data type? Data type primarily divided into primitive and non-primitive. Okay, if you look at the primitive as well, it is further divided into 4 categories. One is the integral or the numeric values. Second one will be the floating point. Third one will be for the character. Fourth one will be for the logical one. Okay. The integral one means the numeric one. It can be a byte, it can be a short, it can be integer, it can be the long. Then the floating point can be float, then double, and the character will be a char. Logical will be the boolean. Mostly we will be using the logical one for the decision making. Okay. Now you must be wondering that why there are different type of this data type. What is the need in the real programming? Let's see one by one, like in which cases we should go for the byte, in which cases we should go for the sort, in which cases we should go for the integer and all. Okay, just remind, you can recollect that in the session we discussed that even if we are storing the data, it occupies the memory. That means this is something being provided by the compiler, okay, to have the optimized memory utilization. Okay, now let's see what are the sizes of this data type. The byte, it will be of 8 bits. Okay, and short, it will be of 16 bits. That means if we are declaring any byte, okay, it is going to take 8 bits in your compiler. Okay, then if we are taking the short, then it will be taking the 16 bit. Okay, so similarly integer will be 32, long will be 64, then float will be 32, double will be 64, char will be 16 bit. Okay, boolean will be of 1 bit. Now there will be the formula. Okay, you can say it is applicable only for integral type. Just remember that it will be applicable only for integral type. This is not applicable for the other type. That means for other type in the sense that for the float and double and boolean as well. Okay, now we can have the limit, or you can define the range is defined based upon the formula. The minimum value will be 2 to minus 2 to the power n minus 1, and the maximum value will be 2 to the power n minus 1 minus 1. So if we apply the same formula, okay, for this byte, okay, which is the 8 bits, we'll see the range as the minus 128 to 127. Okay, similarly, so let's go more into detail. Like byte, we applied the formula minus 2 to the power 7 to the 2 to the power 7 minus 1. The minimum value will be 128. The maximum value will be 127. That means will be whatever application that we will be developing, if we need a range between plus 127 to minus 128, we should go for the byte because it is useful for saving memory when we know that value will be within the range. Okay, so like when we should use this byte, when the memory conservation is critical and we know the value and the range is between 127 minus 128 to plus 127, and we can work with the when we are working with the binary data or stream. Okay, and the RH will be RH having very many small values. So for now you can say whenever you have the range between minus 128 to 127. Now let's see something by writing one small program. So this is a small program you can see here, right? So you see this is our main method what we discussed before. Now there is a minimum and maximum value. So from where we see that the minimum and maximum value, which will be the minus 127 to plus 127, and it is based upon the formula that we calculated before, that is already calculated before. Okay, now let's try to print it and we'll see what the compiler is doing. And I have defined one variable byte b equal to 10 and I have printed the value. Let me try to run it. Okay, so what you see here, that the minimum value, that will be the minus 127. You can search for the different functions as well, like associated with this byte. So I have printed this minimum value. Okay, now the maximum value we see this 127 and byte is byte b equal to 10. Let's do one thing. Let me do byte b1 equal to 1 to 8. So our range is from minus 1 to 7, 1 to 8 to 1 to 7. I am giving value as the 8. Okay, what will happen here? Let me try to print it. Byte value, updated byte value. Let's see, the updated byte value will be kind of B1. Let's try to run it, and what we'll see, you see here, Java incompatible type, the possible lossy conversion from integer to byte, because my range is from minus 1 to 7 to minus 1 to 8 to plus 1 to 7, and I have given a value which is out of the range. That's why it is saying no. It will cause you the logic conversion from integer to byte because it is treating as the next one. Okay, so I think you are clear, like what is the maximum range, what is the minimum range, and if I print it at the 1 to 7, it will be working as expected because it is within the provided range of the byte. Now let's see some practical application where in general you will be using this byte one. Okay, so consider a scenario. Okay, the temperature sensor, right? So if you see the temperature, we always expect within the byte range, that is minus 1 to 7 to plus 1 to 7. So in using the temperature sensor calculation, we can take the byte data type because we know the range cannot be more than that. Next one will be, you can take consider of the volume control, right? When we have the simple audio system, okay, with volume level from 0 to 100. Okay, so whenever we will be developing any application regarding to the volume control, we can always consider the byte as the data type because it is perfect for saving the memory, and we know the value is not going to exceed beyond 120, beyond 100, which is within the range, that is 127. I hope you are clear about the byte one. Now next come to the next type of data type, which is the sort. So let's apply the same formula. Okay, the which will be minus 2 to the power n minus 1 to 2 to the power n minus 1 because this is of 16 bit. Okay, now minus 2 to the power 16 minus 1 is the 15 to 2 to the power 15 minus 1. That means my sort data type range will come between -32768 to 32767. Okay, now let's see the next one where to use the sort. Okay, the sort is the next level of the byte. So when we find out that byte is too small, okay, and next will be the next to the sort will be integer. So we know that if something is between the byte and integer, that means the value is falling between the -32768 to +32767. Then we can use the sort here. For example, like item counts, right? Maybe the year value or maybe the audio sample. Okay. Now let's see the similar range and the example for the sort as well. Let me comment out this one. Let's try to observe for the sort. Okay, this is the sort. I have again taken the sort min value and sort max value, then I have printed them. Okay, then let's see by running it. You can see the sort min -32768, sort max to be this one. Then if I will be taking sort is equal to, let's see this, let's try the similar way that we did 8. Okay, then s out system out.println s. Let's try to run it. Again, Java incompatible type, possible lossy conversion from integer to sort. Okay, so we clearly see that what is the range of the sort. Okay, let's see the application of the real world that we can use. Okay, maybe you are managing a small store. Okay, so for most of the product we will be having the less than 30k items in the stock, so we can go for the sort in this case. Second one will be for the elevation mapping. When we creating a topographic map, we might need to store the elevation. So most elevations on the R that fall within the range of -11k feet to the 30k feet. So in these cases we can use the sort one. Now let's go to the next data type, which is the integer. Integer is having 32 bits. Okay, and it is having the range from -2 to the power 31 to 2 to the power plus 31 minus 1. That is, this is the minimum value and this is the maximum value for the integer. Okay, now when to use the integer. Okay, for most of the whole number calculation, okay, then this is generally the default choice for counting, indexing and general integer arithmetic. For the loop counters and the array indices, representing the most real world quantities, so like population, distances in meters and everything. So most during our programming journey we will be mostly using this integer one. Okay, and if we look at the some real life application for using the integration, we can see like a step counter app, right? We all are having the smartwatch, and even if in the mobile also we are having the application that count our steps as well. So for any fitness application that count the steps, and integer should be the ideal. Like we are having the daily goal to the 10k steps or to 15k steps, and the very most person may not exceed 2.1 billion steps. So in this case, integer is a good option to take as the data type. Then online storing product ID, right? For any e-commerce website, product IDs are the perfect use case for the integer data type. So because most of the online store, they are having the fewer than 2 billion of unique product. Okay. Similarly, like you can try on your own for this integer one by typing the integer mean, integer max, and you can play around the integer one. Okay, like it is just we just went for the byte and short, and for every other data type you can try. Okay, the next one comes is the long data type. So it is just 64 bits. Okay, that means it will be having the range from minus 2 to the power 63 to the 2 to the power 63 minus 1. We need to use this data type when we need a wider range than integer can provide. Let's see for the details as well. So it will be mostly for the large whole number that exceed the integer range. Okay, for example, we are working time in the millisecond for the time stamp, the duration, the file sizes, the memory addresses, and other large quantities. When we need to avoid overflow in the large calculation, we can go for this long one. Okay, for example, we can take it the example of the social media viewer counter. Okay, for a viral video platform, we need to count the views. Okay, popular videos may exceed billions of views, making the long the best choice. Okay, similarly, the bank account balance tracker for a banking application that tracks our account balance in the sense. Okay, to avoid floating point issues, long is appropriate. Okay. Similarly, the next data type is the floating point data type, which is of float is 32 bit and double is 64 bit. Please note that we cannot apply the numerical data range formula that we were applying till now for the integer, numerical type of data type like byte, float, integer, long. Okay, so this floating point can represent a much wider range of values than integer type, but with limited precision. Okay, like if you see, it is having approximately 7 decimal digits, and the double one is having 15 decimal digits. Okay, now let's see whenever we go for this floating data type and when to go for the double data type. Okay, you can see the range here. Okay, for the both float and double. So when we should be using the float, like when memory is the constant, that is and we need only up to 7 digits of the precision. Okay, mostly the graphics application, 3D coordinates, colors. Okay, similarly, when we should go for the double, this is the default choice for the decimal value, more precise than float, you can say. And while going for the scientific calculation, okay, where the precision actually into the matter, we can use the double for the financial calculation. Okay, now let's see the real life example, like where we can use the float, mostly the weather of temperature. Okay, we know that we only need 1 decimal place of precision. In that case, if we are developing any application that is related to any weather temperature application, we can go for the float in this case. Second one is the fitness of BMI calculator. So when we see the number of steps, we prefer the integer one. Now when we are calculating the BMI calculator, that we know that generally the BMI we don't show more than 1 digit. So in this case, we can also go for the floating application. Okay, similarly, when to go for the double, so if you go for the like we discussed for the scientific calculation, okay, which require very high precision, we need to use the double one. Then the financial calculator. Okay, so because the double is going to provide the better precision than float, in this case we can go for the double data type. Next type of data type, which we have the character and boolean data type. So for the character, it will be 16 bits, right? So it will be range from 0 to 2 to the power 16 minus 1. The minimum value will be 0, or this Unicode character. Okay, and maximum value will be 65535. Okay, there are only two. Similarly, for the boolean, we will have only two possible values, which will be either can be true or can be false. So it does not follow the range formula because it is having only two values. Either it can be true or it can be false. So we will be using the boolean mostly during the decision evaluation phase. Now, when to use the character, okay, for single character or symbol, okay, maybe when working with the individual Unicode characters we can go for the char, okay, and we need to work with the ASCII or Unicode value daily directly, so at that time we can go for the char. Similarly, the boolean one, when we need to use it for the conditional logic or decision making scenarios, like if we need to store yes or no, okay, on or off, maybe true or false, okay. So it will be mostly for the flagging purpose, which will indicate that something has happened. Okay. Now let's see the real world example. So in case of character, we can go for the grading system. Like in the exam, we have the different grades. So single Unicode characters like a 9, this dollar. So if we are developing any application that is related to the grade system, if you score greater than this, you will be allocated the grade A. If we see here, right, character grade A equal to grade equal to A, okay. So the passing grade, it is defining that grade meaning A or failed, okay. If the candidate is passing, the student is showing it as a student pass, okay, as the student is getting as a failed. So this if else and all those conditions we will be covering in the upcoming lectures, okay. But for now, just remember where to use the character. Second one, for the display of the initials, okay. If we want to display the initial of a person, the single letter, like if you see here, right, character first initial will be as S, this is a single character, then the last initial will be P, okay. So this is how we will be using the char. Next one will be the boolean data type. So this is widely we are going to use in our programming, mostly in case of the decision making, okay. So like the flags and switches, if you see here, like light switch, it's kind of the on and off, okay. So if the light is on, then if you see here, right, boolean is light on, which is true. So we are printing out light is on, okay. Then we are toggling the light, right. So is light on, this kind of the operators and all will be covering the next one. But just remember, just in case of the on off cases or the true false value, it will be going for the boolean. Like another scenario, so when we'll be using the Selenium in future as well for the web automation, for if you want to find out if any user is logged in, okay, to verify the status, so we can use this one, the login status and all. So overall we have covered all the primitive types of data types. So again, just put in your it's kind of the mind map. That's what we need to, maybe after the covering of the non-primitive ones we'll see the mind map. But for now you can see we have covered the data type, the primitive, the numeric one, byte, short, integer, long, the ranges, and when to use byte, when to use short, when to use integer, when to use long. Similarly, floating points, the float and double, when to use float, when to use double, and then character and logical, okay. So mostly numerical, then floating, then like character one, then decision one, okay. You can take a note of this Java primitive type ranges, okay. This is a quick summary, maybe it will be helpful for you. A tabular one, okay, that is the different type of data bytes, data type, their type, the size, their minimum value and maximum value, okay.